Okay, so here we have that according to the Census Bureau, 13% of American adults age 18 and over are Hispanic. An opinion poll plans to contact an SRS, or a simple random sample of 1,200 adults. What's the mean number of Hispanics in such samples? What is the standard deviation? Okay, so here we're gonna use the formula for the mean of a binomial distribution, because essentially, looking at it in the sense where if you're gonna pick, someone, at random from a population, they're either gonna be Hispanic or they're not, and they're gonna have, in this case, a 30% chance of being Hispanic, or an 87% of not being Hispanic. So it satisfies the binomial condition, the Bin's condition. They're going to be independent. There's a fixed number. We're selecting 1,200. There's 1,200 trials, and each the chance of success is always the same. So this is a binomial random distribution. So for the mean, we're going to use the formula, and let's use this proper notation, mu sub x. Simply going to be NP. N is the number of trials or number of adults in the sample, so 1,200 times the probability of a success, or 0.13. 1,200 times 0.13. That'll be about exactly 156. And then standard deviation of x, using the formula again, will be this, or not the same formula, but formula for the standard deviation of a binomial random variable will be this. And these two formulas are given in your formula packet, so you don't have to memorize it. Don't worry about that. Again, this is just simple algebra. Hopefully it's simple algebra. 1,200 times 0.13 times 1 minus 0.13, or 0.87, all square rooted. That'll be about 11.65. Okay, now part B is asking, should we be suspicious if the sample selected for the opinion poll? Oh, I kind of worded that weird. Should we be suspicious if the sample that is selected for the opinion poll, if it contains 15% Hispanic people? So, like, for example, so in other words, if we take a simple random sample of 1,200 adults and we get 15% Hispanics or more, should that be like a big deal? Is that like is there something suspicious going on? Like, does that mean this is like not correct? So what we want to do is essentially calculate the probability of getting 15% of 1,200 or greater in a binomial random variable distribution. So let's first find what 15% of 1,200 is. So 0.15 times 1,200. So 180. So we want to find the probability of getting 180 or more Hispanic people in a sample of 1,200 adults. So again, you're like, well, how is a binomial random distribution? It kind of, it's kind of weird to think about at first, but when you actually put it together mathematically, your number of trials is 1,200. So you have your n 1,200. The probability of success is 0.13, and k is, your NPK is 180. So the probability that you'll get, k greater than or equal to 180. Now we can do this with the formula, which will take a little, more time by hand, and again, you can just use the formula sheet. But I advise you to, use a calculator, function. Now, the only thing is, the calculator can't find greater than or equal to when in binomial random distributions. It can find less than less than some value, but it can't find greater than or equal to. It can find less than or equal to, in other words. So what we want to do is look at this as being the same as 1 minus the probability that x is less than or equal to 179. Let me separate that. Because the probability that x is greater than or equal to 180 is equal to 1 minus the probability that x is less than or equal to 179. So what we're going to do is find this calculation in our calculator, and then we can get our answer. Now, the reason, again, for that is because your calculator can't do, greater than or equal to, you can do less than or equal to. So what we have here will be 1 minus the binomial CDF function. Let me just show you what it is. So 1 minus, and go to distribution, binomial CDF, and the syntax will be NPK. So 1200 P.13 K 179. Now, see, we do 179 instead of 180 because it does less than or equal to in its calculation. If it was less than, then we could do 180, but it does less than or equal to. So in the calculator, again, the syntax will look like this, but let me just write it out. It'll be N is 1200. Well, I have it right here. I guess I don't have to write it out, but here it is just in case. And then K will be. Actually, well, so the K in this case will be a little different. And PK will be 179. Now, again, if you have a more recent or updated version, it'll be easier to to know what to plug in, because it'll tell you like trials or probability. Like it'll be very clear what to enter for your values, so you won't have to memorize the syntax. This is an old school calculator, so you have to memorize everything. In either case, you're going to get about 2.3%. Now, keep in mind, we get the 2.3% because we did 1 minus that. So this part right here is about like 98, 97%. So let me just show you again, because I don't want, sometimes students get confused, or sometimes it's a little too much at once. But if I just did, again, binomial CDF and PK 1200 P.13 K 179. If I just did that, I should get about 0.98. Which I do, yeah, see. So this is really 1 minus 0.9765, which will then be about 0.0235-ish. Now, we're not done. Let's make sure we answer the question, like, should we be suspicious? This is the probability you get, but now should we be suspicious if we get 50% or more of Hispanic people in our sample? Now, let's think about this for a second. We're suspicious of things when the chance of that thing happening is rare. Like, we're suspicious if you flip a coin 20 times and you get 20 heads. You're like, what the heck? You're like, well, some of this person's, got some, some wizardry or some, doing some, black magic or something. Something's going on. Because we know intuitively that the chance of getting a coin and flipping it 20 times and getting heads 20 times in a row is pretty low. If I told you flip a coin twice and get 2 heads, you're like, no big deal. Even 3 heads, 4 heads. Once you start getting, probably past like 7 or 8, you probably start getting suspicious. If I tell you 100 heads, for sure, you're super suspicious. Anyways, this is a pretty low probability for the most part. It's not out of the realm of possibility, but it's pretty low. So we're probably going to say we were going to be somewhat suspicious because this is a low probability, meaning the chances of this happening, if this were true, if this is the actual, proportion of Hispanics, the chance of us getting 180 or more is only about 2.3%. So yeah, we're going to be suspicious.